The science of the TARDIS. Is time travel really possible? From the blue box of Doctor Who to the chalkboard of Albert Einstein, the dream of leaping through the ages has captivated us for generations. But does the universe actually allow it? We dive into the physics of time dilation, wormholes, and why the past remains so stubbornly out of reach. By Science Features Editor. For 60 years, a madman with a box has convinced us that time is nothing more than a big ball of wibbly-wobbly, timey-wimey stuff. In the world of Doctor Who, the past is a tourist destination, and the future is just a lever pull away. But back on Earth, physicists have been grappling with a much more rigid reality. The surprising news? Time travel isn't just science fiction. It's a documented physical fact, provided you're willing to travel in only one direction. The one-way street, heading to tomorrow. If you want to see the year 3000, physics has a relatively simple, if technically difficult, recipe. Go fast. According to Albert Einstein's special theory of relativity, time is not absolute. It stretches and shrinks depending on how fast you move. This is called time dilation. We see it in action every day with GPS satellites. Because they orbit the Earth at high speeds, their internal clocks tick slightly slower than ours. To the satellites, the future arrives a fraction of a second later. If we could build a rocket capable of reaching 99.9% of the speed of light, a few years of travel for the crew could equate to decades or even centuries passing back on Earth. You would step off the ship into a future you shouldn't have lived to see. In this sense, we are all time travelers, just very slow ones. The gravity shortcut. Einstein's general relativity adds another layer: gravity. Massive objects, like black holes, warp the fabric of space-time itself. The stronger the gravity, the slower time flows. Theoretical physicists, including the late Stephen Hawking, explored the possibility of wormholes, tunnels through space-time that could theoretically connect two different points in time. If you could anchor one end of a wormhole near a black hole and the other near Earth, you might create a bridge between then and now. The grandfather problem. While traveling to the future is a matter of engineering, traveling to the past is a matter of logic. This is where we run into the grandfather paradox. If you travel back in time and accidentally prevent your grandfather from meeting your grandmother, you would never be born, which means you couldn't have traveled back in time to stop them in the first place. Nature seems to abhor a paradox. Stephen Hawking famously proposed the chronology protection conjecture, suggesting that the laws of physics will always conspire to prevent macroscopic objects like people from traveling backward to change history. Even if the math allows for closed time-like curves, the universe might have a built-in delete button for anything that threatens the sequence of cause and effect. The verdict. So, can we build a TARDIS? Not quite. While the future is a destination we can reach with enough speed, the past remains a closed book. For now, the only way to visit the Roman Empire or the 1960s is through the flickering screen of a television. And perhaps that's for the best. After all, the universe is complicated enough without us rewriting the script.